Has working at the office changed your wrists for the worse? Trying to satisfy your thirst, but your carpal tunnel is just acting up? Mundane tasks just get harder and harder every day. Well, your wrists shall suffer no more. Introducing the CASA Device.
Hi, my name is Eric Panetta, and I am a mechanical engineer on the project.
Hi, I'm Brooklyn Freeman, and I'm a mechanical engineer on the project.
Hi, I'm Ryan Mitzdeifer, and I'm a biomedical engineer on the project, as well as the team lead.
Hi, I'm Ali Arashidi, and I'm the industrial engineer on the project.
Hi, I'm Sabina Romero, and I'm a biomedical engineer on the project.
Hi, I'm Alan Lin, and I'm a mechanical engineer on the project.
Hi, my name is Alex Moncada, and I am the procurement lead for the project, as well as a biomedical engineer.
And our team has been hard at work to create an innovative and sleek solution to the carpal tunnel problem that affects 1 to 5% of the population, which is 82 million to 410 million people.
When a patient has carpal tunnel syndrome, the pain they experience is brought on from the transverse carpal ligament applying pressure to the median nerve.
As it stands right now, there's one primary solution to carpal tunnel syndrome.
Are you 1 to 5% of the population that suffers with carpal tunnel syndrome? Do you have $7,000 laying around? Do you absolutely love having your transverse carpal ligament ripped in half? Well, we have a solution for you.
The primary solution for carpal tunnel is a surgical procedure in which the transverse carpal ligament is surgically spliced. This relieves the pressure on the median nerve, but also permanently erases the transverse carpal ligament's functionality. And if you love this, you're going to love the fact that it costs $7,000 per hand.
Luckily, this isn't the only option. Introducing the CASA Device, the world's first non-intrusive wrist brace that relieves the symptoms of carpal tunnel without immobilizing the hand. This grants patients the options to live a pain-free life of normalcy. With the CASA Device, arduous tasks like quenching your thirst are effortless.
Our device's complexity is in its simplicity. It utilizes 3 main components: the brace, the wrap, and the button. These 3 components work in conjunction to stabilize the thumb and pinpoint a force to the pisiform.
By decreasing the distance between your pisiform and trapezium, the transverse carpal ligament loosens around the median nerve and the symptoms are relieved. With the CASA Device, using your hands is no longer an issue. Let our buttons do the pressing so you can do yours. Thanks, CASA Device. With our device, 410 million people can be saved from their never-ending pain. That's like if the entirety of the United States and Canada all woke up with wrist pain.
You may be asking yourself one question: why should I care? Well, let me tell you. If you use your hands for work, then you are at risk of carpal tunnel syndrome. It affects various careers, notably office workers, factory workers, healthcare professionals, musicians, construction workers, retail workers, and drivers. From college students to barbers, your life could get a whole lot harder.
And if you were thinking about getting transverse carpal ligament surgery, let us tell you the biggest benefit of our device: the cost.
When you're aiming to reach even 1 to 5% of the global population, your product has to be cost effective, and we've done just that. Right now, our brace system costs only $13.41 to make. That includes 82 cents for the TPU filament, 12 cents for PLA, 17 cents for an elastic wrap, 8 cents for Velcro, $3.23 for antimicrobial foam, and $9 for skin-safe tape. And remember, that's at a low manufacturing rate. If we scale up, we could cut that cost nearly in half, to about $6. To put it in perspective, surgery to rip the transverse carpal ligament in half costs around $7,000. Our brace is just 0.2% of that. Or, if you flip it, the surgery costs 522% more than our entire system. Now that's expensive.
With the CASA Device, we are saving lives and saving dimes. While it doesn't cost a lot to manufacture, it took multiple iterations to arrive at our current design. We started with a couple ideas on how to apply the force, which ranged from medical balloons to electromagnetic compression systems. But after 18 iterations, we finally arrived upon our design. We landed upon a simple design that utilized Hooke's law. This states that the force from a spring will be proportional to the material's intrinsic stretchiness and the displacement it experiences. We applied this theory to our design.
Our brace is designed specifically to stabilize the thumb and provide a clear opening to the lateral side of the hand, where the pisiform bone is. This is accomplished with the geometry of the brace and the window section of the brace. We designed our buttons to have a smaller surface area where it contacts the skin in order to magnify the force applied on the pisiform. These are easily applied with sticky tape, and by utilizing Hooke's law, we are able to apply a linear force on the pisiform through the button. This shifts the pisiform slightly and augments the carpal arch space.
And how do we know it really works? Let us verify that for you. According to our sponsor Dr. Lee's research, a constant force of 10 to 12 newtons on the pisiform must be sustained in order for the carpal space to be properly augmented. In order to do so, we applied a force sensor to our pisiform, which displayed into an Arduino what force it received. From our verification test, we labeled this as a pass, as our force stayed at the 12 Newton range. Our sponsor also required us not to have any force drop off over the time frame of 1 hour, as patients would need to wear this brace for an extended period of time, which is why we've had this device on this whole time. We labeled this also as a pass as we wore the device for 1 hour with no discomfort, loss of circulation, nor permanent damage. We received readings around 11 newtons with up to 1 newton margin.
We studied and referenced 3 main engineering standards, first being ASTM D638, where we were able to ensure our TPU material performance under load, especially when applying 10 to 12 newtons of force to the pisiform bone. Second being ISO 10993-1, as the device will be worn for longer periods of time, like 1 hour. Biocompatibility and hypoallergenic properties must be verified from our suppliers. The third being ISO 13485, where especially when in large-scale manufacturing, we ensure that the design, production, and testing processes align with quality expectations for a wearable medical device.
So if you're tired of braces that are too bulky to wear, too obtrusive to your everyday life, and too ugly to wear around town, then say goodbye to painful doorknobs and say hello to the new CASA Device, so that you can live the right way, the CASA way, with the CASA Device, or su casa es mi casa.